In problem 4, we have x values, we have y values corresponding to those x values. We want to draw a scatter diagram. Scatter diagram is very simple. We just draw the x, y points corresponding to these values. So the x values go 45, 55, 65, 75, 85. Okay, and I'm not going to label them all, but I'll label at least these three, and it should be clear what the others mean. And the y values go from 1070 up to 1937. It's basically from about 1,000 to a little less than 2,000. So let's put those numbers on here and then break that in half. So where we have 1,500. Let's break those two intervals in half. We've got 1,250 and 1,750. And then we estimate where these values go. 1070 is much closer to 1,000 than 1,250, but it is a little more than 1,000, so that goes with 45. So here's our point, 45, 1,070. I'm not going to label every point, but just to orient you to what we're doing here. There's the point that corresponds to our first pair of data points, our first pair of data coordinates. Okay, the second data point is 55, 1309. Here's 55, halfway between 45 and 65. And 1309 is going to be a little more than 1250, so maybe about here. We come over here, we come up here, and we get a point that looks something like this. Now, on a test, you are going to do these graphs freehand. Just make sure that your x scale is consistent. That is, every mark is the same number of units from the last mark, if the marks are equally spaced, and every equally spaced mark on the y-axis is the same difference from the previous one. Okay? You do want to do that, otherwise you're not going to get a good graph. And of course you don't have to be exact. I noticed that this interval here is maybe 20% shorter than the interval I have marked here. That's okay, but you don't want to have equal marks that go like 2, 5, 48, 397, 10,486, where you're labeling equal marks with intervals that are not equal. Okay, so just a warning about that. Okay, so 65, 1510, well, that's close to 1,500. 65 is here, so we have a point here. 75, 1,797. 1,797 is a little greater than 1,750. And my intervals are kind of getting fuzzed up here. Again, if you don't do any worse than I did here, you're doing fine. 1937 is a little less than 2,000, and that goes with 85. So it's here. Now, the problem asks you to fit sketch an estimated best fit line. Use 2 points in that line to make an estimate of the equation of the line. So to do a best fit line, I just draw a line. I don't go through any of the data points. I stay as close on the average to data points as I can. I make no effort to go through any data point. Now, I accidentally kind of went through the middle of this one. I'm a little above the middle of this one, but I'm certainly below this one, and below this one, and below this one. So I probably should have made the line a little higher. But one thing I absolutely do not do in drawing a scatter diagram is go through the first point and go through the last point, unless that happens to get me right through every other point. As exactly as I go through the first two. You want to adjust this line so the average distance between the line and the points is as low as possible. Okay, so this line should probably adjust up a little bit. Maybe it all raises up by the same amount. Maybe I change the slope by a little bit. But this is reasonable. Now, it says use 2 points on the line. We don't assume that any of the data points are on the line. We pick 2 points on the line. So I'm going to say, let's say, if 45 is here, I think we can squeeze in 40 right here. Now you notice I've got a break in the axis here and a break in the axis here. Those are unspecified breaks, so I don't want to extrapolate this back to the line where 1,000 is here and 2,000 is here, because clearly 0 is not going to be here if that's the actual scale. If I continue spacing these marks equally, this axis would be at 1500 or so. We don't want to do that. I put the breaks in these axes here so that the graph would spread out as much as possible and give us a fairly reliable potential for getting the points right. So I'm going to estimate anyhow that the coordinates of this point are 40 and let's say 1900. So I'm going to say, okay, here's the point 40, 1900. That's this point. Okay, now over here, of course I've got 85. Let's just, the x-axis doesn't go far enough to estimate 90, but I'm going to extend it a little bit. So 90 would be about this far to the right of 85, so here's 90. And let's see what happens if we go up to the 90 and we come over here. I think that gets us just a little over 2,000. I'm going to estimate the coordinates of this point to be 90, let's say 2050. Now these are just estimates. Okay, that's questionable. This is questionable, but they aren't bad estimates. Now based on these estimates of the coordinates of the points, what's the equation of the line? Well, first of all, how do we get the equation of a line from 2 points? Knee-jerk reaction ought to be, if you got 2 points, you draw the triangle, the right triangle, with horizontal and vertical sides that go from this point to this point. And we see that the run from this point to this point is 90 minus 40, that's 50. And the rise is what? From here to here? Well, we're going from what I think is 1900 to 2050. That's 1150. Now, let's actually calculate that. The rise is 2050 minus 1900, and it's not 11. Okay. I said 1900, it's actually 900, obviously. 1900 would be up here. We're a little less than 1,000. I estimated that as 900. I probably said 1900, and I thought 1900, but I know better. Okay, you got to be careful. Don't do like I did. Okay, 1150. The run is 90 minus 40 equals 50. So the slope is rise divided by run, which equals 1150 over 50, which equals 23. Okay? And check my division. I think that's right, but I'm not going to take it to the bank. Okay, so we have the slope of our straight line. Now, where are we? We started with data. We plotted our data. We fit a straight line that fits pretty well to the data. And we took 2 points on that line, not data points. And on the basis of those 2 points, at this point we've calculated the slope of the line based on these estimates of the points. Okay? Now let me move the board over here because if I do I won't block it as badly. Okay, we have this information. So we have points 40, 1900, and 90, 2050. We have slope 23. We want to find the equation of the line. Well, there are various forms you can use. You could go to the slope-intercept form and plug in the coordinates of one of these points along with the slope, and you can find the intercept and you can find the equation. So we could say, okay, slope-intercept form is y equals mx plus b. M is 23. use y equals 1900 and x equals 40 to get an equation. So that's going to be 1900 equals 23x, well, 23x is 40 times 40 plus b. Okay, and we solve for b. We get b equals 1900 minus 23 times 40. 23 times 40 is 920. Subtracting that from 900, I think we get 880. So the equation is y equals mx plus b. Y equals 23x plus 880. To check this, we can plug the coordinates of this point in. They should give us an identity. Now, I'm not going to do that. You should do that. We check by substituting. X equals 90. Y equals 2050. See if you get an identity. If I've done this correctly, you will. If I haven't, correct me.